Okay, so the sign tells you that it's already there. So, all right, so for this example, you would say if you want to find the values of A1, A2, and A3, that would just mean plug in 1, then plug in 2, then plug in 3. That's it. All right. So here we'll have A1 as 1 squared over 1 plus 1, and that'll be 1/2. You have A2 as 2 squared over 2 plus 1, and that'll be 4/3. And you will have A3 as 3 squared over 3 plus 1, so that'll be 9/4, and so on. So that's the first kind of sequence that you can have. The other way the sequence could be defined will be what they call recursively. So you have a recurrence relationship between the terms of the sequence. Instead of giving you a formula for an, they give you a relationship between an minus 1, and an plus 1. For example, let's say you have 2an minus an minus 1 equals 3an plus 1. And then they give you a1 equal 1, a2 equals 3. So usually when you have a recurrence relationship that is given between the terms, if you have 3 terms in the recurrence relationship, they give you 2 initial values, because you will plug in the 2 values to find the third one. If you have 2 terms in the recurrence relationship, then you will have 1 initial values. If you have 4 terms, then you will have 3 initial values to be able to use that recurrence formula to find the following terms. For this example, I can solve. So this solves as an plus 1 equals 2/3 an minus 1/3 an minus 1. So the index n minus 1 here means if you take, for example, n equals 2, 2 minus 1 is going to be 1. So there will be a1. This will be a2. And 2 plus 1 will be 3. The right-hand side would be a3. So n equals 2. In this case, that would mean a2 plus 1 equals 2/3 a2 minus 1/3 a2 minus 1. And that will turn into a3 equals 2/3 a2 minus 1/3 a1. You see that? So those are the activities that you can have with the indexes. So when you see this, you know it's just the number that was supposed to be n minus 1. Here it's just that n, and here it's that n plus 1. You plug them in and you see the index you have. Here you have 3, here you have 2, and there you have 1. Now when you look at this formula right here, you have a1. You see a1 was given to you, right? So you can plug it in. You have a2. a2 was given to you. You can plug it in. So you plug in a1 and a2, you get a3, right? So the a3 that was not given to you is now found here as 2/3. A2 is 3 minus 1/3. A1 is 1. So that is 6 minus 1, 5/3. So this is A3. To find A4, I plug in n equals 3. If I plug in n equals 3 in this formula, that will be A3 plus 1, that is A4, right? That's A4 equals 2/3. N is 3, so that's A3 minus 1/3. N minus 1, n being 3, n minus 1 is 2, so A2. Again, now you look, A2, see that? A2 was given to you. A3, you just found it. So you know A4. And that's how what you call the recurrence relationship. So you use the previous values to find the next. You use the previous values to find the next and build them up to find all the terms of the sequence that you need. Does that make sense? Any question on this, please? So again, when you have this kind of relationship, you use the terms that are given to you and you build on it to find the next terms. So here, this is going to be 2/3. A3 is 5/3 minus 1/3, and A2 is 3. So that gives you 10/9 minus 1. So that is 1/9. So this is A4. And so on. Now, when you have sequences defined like that, the question you ask yourself is, what can we do with these sequences? Can they just compute? When we compute them going on, do we just keep computing, or is there any time it's going to stop at a certain value and not change very much? So the answer to that question is, if it stops like that, that means you have reached a limit, which is the same concept that you had for functions. So limits of sequences do exist when this procedure gets stuck somewhere to a number that doesn't change very much again. You will call that the limit of the sequence. And when you have a sequence that is defined like this with a formula, you find the limit the same way we find limits of functions. For a polynomial, you know it's a ratio of the highest powers of n, right? So the example one we have here, if you have an equals n squared over n plus 1, this is a ratio of polynomials. For the ratios of polynomials, we say that the limit is the limit of the ratio of the highest powers of n. So the highest power of n for the numerator here is n squared, right? And the highest power of n for the denominator is n. So you would say that the limit of this sequence is equal to the limit of n squared over n as n goes to infinity. And n squared over n is what? N. What is the limit of n when n goes to infinity?
Would it be infinity?
That'll be infinity. So in this case, you have that the limit is infinity. That's it. Does this make sense? Is there any questions, please? Example 2. If I have an equal 2n cubed plus 5n over 6n cubed minus n squared, you tell me what will be the limit as n goes to infinity of an equals to limit of what ratio? What will be the ratio in this case?
The papers will cut off. Would you mind moving it up?
Can you see?
Yeah, that's better. Thank you.
So what would be the ratio in this case? For this sequence, what ratio should I take to get the limit? It should be the highest powers of n.
So would it be 2n cubed over 6n cubed?
Great, that's it. Thank you. So that's the first rule that you have for limits. When you have ratios of polynomials, you just take the highest powers of n and then you do the ratio to see what you have there. Now n cube cancels, right? Now you have 2, 6, and 2, 6 is nothing but 1/3. That's it, and you have your limit. Is there any questions on this? So now I just gave you the definitions of a sequence and then a few examples for which we wrote down a couple of terms. We wrote down a couple of terms here. Find A3, A4. You have on the practice problem things similar to this one on which you can practice for different sequences that are given. I'd love to see that done. If you have questions, please get back to me and I can explain more if necessary. Now, now you have in this chapter something called series. So today is like kind of some generalities, and then in the next lectures we head into more serious things, right? So what you call a series is like you have some numbers a1 plus a2 plus a3 plus, and this continues going where with the dot meaning that it keeps adding, it doesn't stop. Where a1, a2, this set is a sequence. So you use a sequence is called a series. So when you take a sequence, A1, A2, A all the way to infinity, and you add all the terms, when you add all the terms of a sequence, it's really crazy to say you add all the terms when you're saying they go all the way to infinity. Yeah? How do you add infinitely many things? That's one of the things that we will learn in this class. You never did something like that, actually, prior to this class. How do you add numbers all the way to infinity? Infinitely many numbers, you're adding them how? So this is what this is about. All right. And so we say you take a sequence and you add all the terms of that sequence. the act of adding all of them is what you call the series. You add all those things, you call that a series. And the main question that we will have will be, how do we handle this? How do we add infinitely many things? How do we know that by adding this thing, it actually stop at some point and give us a number that doesn't change anymore, that we will call a limit, right? So we'll have about 6, 7, 8 lectures on that. Okay. And I think we covered that on like 2 tests. So it'll be 2 tests only on that topic, knowing how to add these things. There are various rules, various theorems that we will use for that. And so when we have a series that is defined like this, there is something we call the partial sums of a series. So when you have this series, and in life, usually what we do is when we are asked a very difficult question that we don't know how to answer, we try to bring it back to something that we know, right? And we say something about it based on what we know. And we hope that it's going to be true. And so this is that rule right here. So we got a series. We don't know what that really is, how to add it. And we say, okay, so we know how to add finitely many numbers. I know how to add 5 numbers, right? I know how to add 6 numbers. I know how to add n numbers. When the number is fixed, I can add them. So I say, let me add n of those numbers, of those infinitely many numbers. Sn is the sum of the first n, the sum of the first n terms of the series. So you take this series, you don't add all the terms because you don't know how to add them. You take an arbitrary number n, that is denoted n, and you try to find a formula for the sum of those n terms. That's what you call a partial sums. So for example, let's say we have 1 plus 2 plus 3 plus 4 and so on. So the sum of integers, right? So here, let's just say an is equal to n, right? And so what is S1 is A1. S1 is the sum of the first number. It's just one number. So that's A1. That is going to be 1. S2 is the sum of the first 2. That's what it says by definition. That's A1 plus A2. A1 is 1, A2 is 2, so that is 1 plus 2 equals 3. So S2 is 3. And you will say S3, 1, that's A1 plus A2 plus A3. So the sum of the first 3, that's going to be 1 plus 2 plus 3, that's 6, right? And that's how you find the S's. Just adding as many terms as the number that you have here for S. And this actually, Sn, is a sequence, right? Because we have defined a sequence as a function that is defined for the integers, right? As you have seen, Sn takes every single n, adds n terms, assigns that number to n. So it is a sequence, Sn. And now the question is, okay, Now that I start adding these things, and I can take the first, add the first two, add the first three, do I have a formula for Sn in general? Can I find, in this case, in this example, can I find Sn? In this example, Sn equal what? What's the formula for this? So I'm pretty sure that some of you already know the formula for this. What is the formula for the sum of the first n integers? Anybody knows? It's a very famous formula, right? Half of something. All right, if you don't remember, it's not a big deal. So it's 1 n times n plus 1 over 2, right? Very famous formula. So if you add the terms, if you add the first n integers, what you get is 1/2 n times n plus 1. So there is a formula for Sn in this case. So that means clearly that 1 plus 2 plus 3 plus all the way to n equals 1/2 n times n plus 1. All right. So you want me to prove this? I can if you want. If not, it's not necessary.
I'd like to see it, I think.
Okay, so the traditional proof of this says, take these numbers, write them first as is, 1 plus 2 plus 3 plus n minus 1, and then plus the last one n, okay? Now go to the next line, write the same numbers backwards. So starting from the largest. So that's n. And then you're gonna have n minus 1. And then here you're gonna have n minus 2 down to 2 plus 1, right? And then add the two rows. So this is Sn. This is Sn, right? I just wrote it backwards. Add the two rows. If I add these two things, 1 plus this, what is it? N plus 1, right? Plus 2 plus n minus 1.
N plus 1.
N plus 1, good. 3 plus n minus 2.
N plus 1.
N plus 1. And everything in between is going to be x plus n plus 1 and n minus 1 plus 2.
N plus 1.
N plus 1 again. And the last one, n plus 1. And on the right, Sn plus Sn?
2Sn.
2Sn. How many terms do I have here? 1, 2, 3. How many?
It's kind of getting cut off at the bottom.
Sorry about that. Can you see now?
Yeah.
So how many numbers have I added there?
Infinitely many, right?
No. 1, 2,
N.
n. So there are 1, 2, 3 up to
N.
n plus 1, right? So that is n times n plus 1 is 2Sn,
Oh.
right? And so you get Sn 1/2 n times n plus 1. This is a very famous trick in those things, right? Are we good? Okay, so that's it. That's it for sums of integers. And the other example that I want to talk about is the limit of something that always shows up in my class, because I just happen to think that students need to know how to do that. on my first day, I always bring this up. How to find limit as n goes to infinity of 1 plus a over n to the power n. This is my famous problem. It comes back all the time in all my exams. I ask you to try to learn how to do that, because this limit shows up in many things that you do. Okay. So how do we find this limit? We use the properties of limits of functions that apply to sequences as well. The first thing you need to remember is if if let's say L is equal to limit of an as n goes to infinity and f is continuous. So this is like recalling what you did in your calculus 2 class for continuous functions. If you have ever continuous function and you have a sequence an that has limit L, then the limit as n goes to infinity of f of an is equal to f of L. So if you have a continuous function and you know the limit of the sequence that is inside of it, you can find the limit of the function of that sequence just as the function of the limit, right? So this is what we are going to use to find the limit of the sequence. And I can tell you right away, the answer is going to be e to the a. But the question is, how do you find it? And that's what I will be grading when I ask you to do that. Okay. Now, when you look at this, the first thing you do, if you don't want to follow what I'm doing in this class, you would think, okay, let me plug in n, right? So that'll be 1 a over n. In a over infinity is? What's a over infinity? What's the limit when n goes to infinity of a over n? A is a number.
It's 0.
It's 0 because that's a number. There is no n there. 0 a over infinity is 0. 1 plus 0 is 1. And you would think, now the guess question, what is 1 to the power infinity? And that's usually where we fail this thing, because we happen to think that from high school, we were taught that 1 raised to any power is 1, right? That's what they always said. And guess what? In this class, it doesn't stand true anymore when we're talking about limits, because 1 to the power infinity in this case is going to be e to the a. It's not 1. So be very careful when you're computing a limit and you see 1 raised to an infinite power. It's not going to be 1 always. So in the proof of that, we're going to see that in this problem. So answer and that's the answer to this question. Finding the limit of 1 plus a over n to the power n. So what you do is you say, you take bn as natural log of an. So you take the natural log to get rid of that power that is disturbing there. You take natural log of an, it's going to be n natural log of 1 plus a over n. This is it. And then we try now to find limit of bn as n goes to infinity instead of finding the limit of an. If we can find the limit of bn, then using this theorem, we are going to say that the limit of an is exponential what we get here, because it's exponential an is exponential bn is an. Am I making sense? All right, so that's what happens here. So we try to find the limit of bn first. And so that's going to be, if we try, this is equal to limit as n goes to infinity. Can everybody see this? So of n natural log of 1 plus a over n. And if I try to compute this now, I'm going to have a over infinity is 0. 1 plus 0 is 1. Natural log of 1 is? What's natural log of 1? Yes, Matthew. So the natural log of 1 you get there, it's going to be 0. 0 times infinity, that's undetermined. You can't say it's 0, you can't say it's infinity. So it's right here, 0 times infinity, same as infinity over infinity, same as 1 to the power infinity. These forms are undetermined. When you hit something like this, when you're looking for a limit, you need to do more work to find the answer. You can't decide just by looking at that, okay? 1 to the power infinity, 0 times infinity, infinity over infinity, then you need to do something. So in this case, we are going to say this is limit as n goes to infinity, and we take this n to the bottom. That's natural log of 1 plus a over n divided by 1 over n. So this is same as that. But the good news now is that it takes us from 0 times infinity to infinity over infinity. Or the other guy here that not infinity over infinity, but 0 over 0. So 0 over 0 is another form of infinity over infinity, which is also undetermined. And the good news about either of them is that you use the L'Hopital's rule. Whenever you have 0 over 0 or infinity over infinity, you can use L'Hopital's rule to find the limit. So here at this point, we are going to use L'Hopital's rule. What does L'Hopital's rule say? It says when you want to find that limit, when x goes to an a and this thing goes to 0 and that thing also goes to 0, then the limit is equal to the limit of the ratio of the derivatives. That's what L'Hopital says. So if I want to find a limit, the top goes to 0 and the bottom goes to 0, that limit is going to be equal to the limit of the ratio of the derivatives. So here, I'm going to have the limit of the ratio of the derivatives of these two functions. The derivative of natural log of 1 plus a over n, that's what I'm writing first on top. Derivative of natural log of 1 plus a over n. It's going to be minus a over n squared. This is the derivative of the inside function. divided by 1 plus a over n. Derivative of natural log of a function is the derivative of natural log of a function is equal to the derivative of the function divided by the function itself, right? That's what I wrote here. Derivative of natural log is the derivative of that function. Derivative of 1 plus a over n is minus a over n squared. And now you have derivative of 1 over n. The derivative of 1 over n, it's minus 1 over n squared. And then limit as n goes to infinity. Now minus 1 over n squared cancels there. And you have that this is limit as n goes to infinity of a over 1 plus a over n. And now you can compute this. When you plug in infinity, a over infinity is 0. 0 plus 1 is 1. A over 1 is a. So the limit of bn is equal to a. Therefore, the limit of an is e to the a. That's it. That's how you use that theorem on limits. And it doesn't matter what a is. I did this in general, right? In your problems, I will put a as a given number like 2, minus 1, minus 2, 3, 4, and so on. And all you have to do is to just repeat exactly this same work that is written here, replacing a by its value. Any questions? All right, so if there's no questions, let me give you this other definition. We say that the series and this series also is often denoted sum n from 1 to infinity an. So this notation means sum, add all the numbers n from 1 to infinity that appear in the sequence. All right. So in your problems, you might either see this written or see that. So we say that the series converges if and only if the partial sums Sn have a limit L not equal to infinity, right? That plus minus infinity, right? So if we have a series and we take the partial sums of the series and we find out that the partial sums have a limit that is not infinity or minus infinity, then we conclude that the series converges and it is equal to L. And we write sum n from 1 to infinity, an equal L. So anytime you see this, that a series is equal to a number, you should understand that the limit of the partial sums of that series is equal to L. So that's how we're able to define how we add infinitely many things. We just don't sit there and literally add them all infinitely many. We take n of them, try to find a formula if we can, or find a way to show that the sequence of those sums that we get converges. If we find that, then we say, okay, it converges, and that sum is equal to L. So in our first example of integers, the sum of integers diverges because all integers add to infinity. All right. So if we add all integers, we go into infinity. So n from 1 to infinity of n diverges because limit of Sn as n goes to infinity equal limit as n goes to infinity of n times n plus 1 over 2, and this limit is infinity. So when that limit is infinity, you say it diverges because that limit is not finite. So we will have a lot more of this next time. Do you have any questions as of now? And again, I would say, please always feel free to ask, because by asking that we all learn. Sometimes when you ask your questions, I actually figure why somebody might not get it. And if you have a question and you don't ask, then you're depriving us of that opportunity. So I can't explain it to you. I don't even know. And the others that might have the same problem don't gain from it, right? So it's always a win-win when you ask a question. So the day I get the most questions from you guys, I'll show you one of my videos of stand-up. Unfortunately, you will not hear what they're saying because it's Russian, but if there are some Russian spies among us, they will understand. Okay, do we agree on that? Is there any question? By the way,
I don't have any at this time.
I love sometimes just pointing and calling people to answer questions, and you don't need to feel bad about that, okay? So especially when we're already in the semester, and I feel like, you know, some people might be getting more and some might not be getting more, and I tend to call on people to participate because that calls you into the class, and you feel more connected. And even if you don't have the right answer, it is not a bad thing. It is good to participate. Yeah. Some people think it's mean. I don't know. That's how I was taught how to teach. So all right, Eve, I guess we are stopping here today. If you don't have any other questions, then we will stop here today. I will not start a new topic on or the series on how to handle them. Well, we just meet next time. Please, again, register on Pearson MyMathLab. Complete the practice problems that we have there. It's very important. And make sure you read carefully the syllabus. And that you apply the instructions that are there and we're just gonna be fine. I always try to expect 100% from all of my students. They say I have high expectations, and I just love thinking that my students can be the best. That's it for today.